So now we're going to discuss the difference between distance and displacement. So this is also in 1D motion. So first, for distance and displacement, what do they both have in common? Well, the first thing they both have in common is answering the question, how far? It's just the way that it does it. But both of them deal with how far. The other similarity is they are both measured in units using meters. So distance and displacement will be measured in meters, kilometers, centimeters, millimeters. If you want to go into standard units, miles, feet, inches, things like that. They both have the same unit. The big difference, distance is a scalar. So reviewing, a scalar quantity is one that only has magnitude. And magnitude, again, as a reminder, is just a number and unit. So for example, 5 meters. That is a scalar. So distance is a scalar. Displacement is a vector. So displacement, when we're talking about a vector quantity, means also direction. So instead of just 5 meters, it would be 5 meters north, negative 5 meters, 5 meters forward, something like that. There is a direction. Another way to give a more specific way of defining these two things is that distance is how far did you go with your feet? Say with feet. So this would be like your odometer in your car. Whenever you pull out of your driveway, it doesn't matter. Your car doesn't care what direction you're going. The odometer is just going to keep turning and turning. Every mile you go, it clicks another mile. Displacement, the difference is how far from start to end. And this is in a straight line. So if you start at your house and you end, say, at Walmart, displacement only cares about how far away you are from your house. You draw a straight line from your house to Walmart, and that distance is your displacement. Sorry, not distance, that length. Why don't we say that? That length is your displacement. The distance that you would cover from your house to Walmart would be turning out of your neighborhood, you went this far, plus you went this far down Cole, plus you went this far down Five Forks, plus you went this far down Rockbridge in order to get to Walmart. That's your distance. Distance is how far did your feet go, or what was the total length traveled. How about that? Let's also put that. Total length traveled. And this is just start to end. How far start to end. You pick a point at your house, pick a point at Walmart, draw a straight line. That's displacement. So to make sure that we emphasize the difference between these two things, let's do a few examples of this. So in example 1, we have Rocky, and Rocky is running the following path. So he starts at this point and he ends right here. This arrow indicates a length of 25 meters. So question 1 is, what is his distance that he covers? Well, he starts here, he follows this path to this point, which is 25 meters. So his distance is 25 meters. Displacement, since it is a vector, so this is a vector quantity, needs a direction as well. So we start here, we end here, and we are going 25 meters in this direction. So the displacement would be 25 meters east. Notice we have to have that directional component. Vector quantity. All right, now let's change it up. So Bill is running the following path. So here's our starting point, and then here's our ending point here. So it looks like he takes two different roads to run this path. So for distance, distance is how far did you go? How far did your feet travel? The total length traveled. Well, he started here. He went 10 meters this way, and then 10 meters this way. So for distance, it would be 10 plus 10. So distance is 20 meters. For displacement, displacement is a straight line from start to end. And that would be this line right here. Notice whenever we add this line in, it makes a triangle. Not just any triangle, but a right triangle. And for a right triangle, I'm going to erase this. For a right triangle, to find this line called the hypotenuse, we have to use Pythagorean. A squared plus b squared equals c squared. Now, you're not going to get a whole lot of this kind of stuff on that first test, but it's more of showing you that emphasis again in the difference between distance and displacement. So this is for our displacement. A squared plus b squared equals. Dun, 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 dun. Sorry about that. Equals c squared. There we go. So a squared is going to be one of our legs, so that's 10. So 10 squared plus 10 squared equals c squared. So 10 squared is 100 plus another 100 equals c squared. So 200 equals c squared. And in order to get c by itself, you would have to square root. And so the square root of 200, one way to write it is 10 square root of 2, right? Because it's the same as the square root of 2 times 100 equals c. There we go. And so you can pull this 100 out because that is 10 squared. So you get 10 root 2. Now, most of the time we're going to be worrying about decimals. And so if you were to do this as a decimal, the square root of 200 would also be, or 14.14 meters. Now notice here I have northeast, because from start to end would be in the northeast direction. So this would also have to have northeast. So 14.14 meters northeast. Either of these answers are correct. For tests and all, I would go with the decimal. Go ahead and get your decimal answer. All right, now, example 3. Jose is running the following path, which is a perfect circle. And here we know that the radius is 5 meters. I'm going to go ahead and draw that in. There we go. All right, question number 1 is always asking about distance. So what is the distance traveled? He starts here and he runs in a perfect circle and comes back to the same spot. Well, this total distance covered, the total length covered, is the circumference of the circle. To find circumference from math, so we'll say D for distance. How about distance? We'll just put distance. There we go. So there's no confusion. So distance is going to be the circumference, which we find by 2 pi r. Again, you're probably not going to see this on the test, but it's just, again, emphasizing the difference between distance and displacement. So for distance, 2 pi r is going to be 2 times pi times r, which is 5. So 2 times 5 is 10 times pi. And so if we were to put in 3.14 for pi. 10 times 3.14 gives us 31.4 meters. That's his distance. Now, displacement is that from start to end. He started here, he ended there. He started and ended at the exact same place. So how far is he from his starting point? Well, he's not. He's at the exact same spot. Therefore, his displacement is 0. Does that mean he didn't go anywhere? Well, in terms of distance, he did go somewhere. He made a complete circle. In terms of displacement, he didn't. He started and ended in the same space. So in a way, it's kind of fun to think about these two terms in terms of what you do every day. Every day, you start in your room, in your bed, and you end the day, usually, right, in your room, in your bed. So every single day, no matter what happens, your displacement's always 0. Does that mean you didn't do anything? Well, of course not. You went a number of different distances. You went the distance from your house to school, and then maybe to a job that you have after school, to different practices, going to a friend's house to study, whatever it is, and then you end back up at your house. So you could have gone all sorts of different distances, but in the end, your displacement was still 0. Just something fun to think about. So distance, how far did your feet actually go? The total length traveled. Displacement, vector quantity. It wants to know how far are you from your starting point. So straight line from start to end.